Hello, Team R. Welcome back for Module 4. So for this week, I'm going to, again, break it up into two chunks. And the first chunk has less to do with multi-level modeling and more to do with sort of getting comfortable in R, data management. And also we're going to talk about how to calculate scale scores and reliability statistics, which is a very common task, I guess, if you're ever working with secondary data or even your own data, and you've collected, for example, questionnaire data where you want to calculate a scale score for a set of questions. So here I have the R Markdown file for Module 4. And this is available. If you follow the link on Canvas, you can actually download this exact file if you'd like. We always start with describing the data a little bit and loading in some packages. So this week we're using data from Gavin and Hoffman, 2002. So if you've read the chapter for this week in Garson, this is the data set that's referenced in Garson. So it's a study of organizational climate in which we have individual soldiers, personnel nested within larger companies in the military. And we're looking at the relationship between a soldier's perception of the significance of their task and their hostility to the overall mission. So, and also leadership climate as well, which is pretty cool. So this is the kind of study that you could do in a lot of different settings, looking at how attitudes and beliefs shape individual outcomes. But in this case, we're looking at an example from the military. So the first thing we're going to load here are our packages. Now you might get more warnings and messages than I did because I already had these packages loaded up. So we're going to load up the tidyverse, which I recommend all the time. We're going to load up the psych package. In particular, psych is very good. Psych is sort of short for psychometrics. And so psych is very good at calculating scale scores and reliability statistics. And so anytime you're going to be doing scale scores or anything like that, it's a good idea to load the psych package. And then our friend LME4 that we got to know last week, this is a good modern package for multi-level modeling. At the end of the handout, we will look at two new packages that you may not have. One is called broom.mixed and another is called model summary, but we don't need to worry about those yet. We're going to use those to put together a really nice summary table of our results, which is going to save us a ton of time. Believe me, as somebody who spends way too much of his job building tables, any package that can allow speed up and automate the process of creating summary tables is really, really nice. So, okay, so I've got those loaded. And so notice, I mentioned this a lot, but I mention it because it's really important. So before I started this, I have navigated to the folder down here under Files, which is holding the place that holds my data. So I'm here in week 4, which is module 4 of this course. And the data is LQ 2002. I have both a CSV and a DTA, a data file. Now keep in mind, R can read any data type, literally any data type. So it can read data files just fine. If you click that and click import, the easiest format to read is a CSV file, but it doesn't have to be a CSV file. You can literally you can open SAS files, you can open SPSS files, you can open any kind of delimited file, tab delimited, comma delimited, you name it, Excel files. So in this case, we have I'll open up the comma separated, the CSV file. So what I'm going to do here, I'm going to give my data set a name in my environment. Notice my environment here is empty. I don't have anything in it yet. I'm going to call this data set LQ 2002, which is the same name as the file. LQ because it comes from this paper that was in Leadership Quarterly in 2002. And then I'm going to glimpse that data set once it's loaded and make sure that I understand what's going on with the data set. So I like to run line by line until I know the code is good. Now in this case, I've kind of vetted the code, so I could probably just push this play button and run everything. But I think it's a good way of troubleshooting your code is to run things line by line and to see where things break down, because that can really help you diagnose what the problem may be. And to run something line by line, you just hold down the control button and press enter or return. And that runs only the line that you're on. So we get a little message here, parsed with column specification, default equals column double. So basically, it's pretty much everything in this data set is going to end up as a double, and I can change that if I need to. And then up here in the corner, I now have a data set called LQ 2002 with 2,000 observations of 28 variables. If I want to look at this in its sort of raw form, I can just click right there, and then I get a sense of the whole data set like that. That can be really useful. I also really like glimpse because it's going to tell me what kind of variable each one of those variables are, so that I know if I need to recode or change anything to a factor, or if something's a character or something else I need to fix. So I'm going to do Control Enter and get a glimpse here. So again, 2,000 observations, which are the rows, 28 columns, which are the variables. Row ID is the individual, you see that as the individual ID, each person. And company ID is the nesting variable. So we have soldiers who are nested within company, just like students who are nested within classroom. And we have, there's good reason. Soldiers probably tend to spend quite a bit of time with people in their company. And so we have a good reason to suspect that outcomes from soldiers in the same company might be related to one another. And that's a good justification also for looking at multi-level modeling. And then we have sub. I can't remember what sub is, maybe a subunit within the larger unit. I'm not entirely sure. And then we have a series of questions about perceived leadership. So in this particular study, participants were asked about the effectiveness of their leader in developing I think it's like a positive climate or something. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 11 questions that pertain to leadership. And those are all basically measured on a Likert type scale. You can tell these are all whole numbers. That's usually a sign that there might be a Likert type scale going on. I think it's maybe 1 to 5. We can double check that in the descriptives. And then we have 3 questions that relate to task significance. This is going to be our covariate of interest. So we're interested in the relationship between task significance and hostility towards the mission. So if someone perceives their job or their task as more important, how does that affect their hostility to the larger goal? And hostility is measured according to these 5 items right here. So we've got 11 items for leadership, 3 items for task significance, 5 items for hostility. And then in this particular data set, the Garson, I think it's Garson, has already calculated the scale scores for us. So we have an overall aggregate scale score for leadership, for TSIG, for hostile, which is really nice. And then we actually have group averaged scores for these things too. So we have a group average leadership score, we have a group average task significance, and a group average hostility score. So just a reminder, in multi-level modeling, anything that you measure at the individual level can also be measured at the cluster level. And so we have measures of leadership, task significance, and hostility at the soldier level. That means we can calculate the mean of those things at the company level. So that would just be like if you could measure students' motivation or self-efficacy individually, and you knew which classroom they're in, you could take the average, the classroom average of motivation or self-efficacy, and then you would have a classroom construct. And the cool thing is those things function differently, right? So one is a measure of an individual's perception, how I feel about my boss, right? If I'm talking about leadership. But if you average that together, it actually is a peer effect. So it's now no longer about me, it's about basically how my peers feel about that same construct. And those two things have very different meanings, right? So you can kind of pit them against each other or include them both as predictors to see, okay, what matters more? Is it what the individual thinks or what the overall climate of the group is? So that's a really cool thing that you're able to do in multi-level modeling. And I'll show you, I don't know if we'll do it this week, but in later weeks, I will actually show you how to calculate a cluster mean. It's very easy in R using dplyr in a few shortcuts that I'll teach you. But it's not hard at all to group people by their company and then calculate those average cluster level measures. So that's what those things are here. And these are scale scores. Okay, so I always think it's a good idea. Here, I'll hide the surprise here. I always think it's a good idea to calculate some descriptive statistics. I showed you how to use, I think, summarize or describe from the HMISC package last week. We talked about Psych has a nice descriptive statistics tool. So since we're already using Psych, we might as well just use describe from the Psych package. And so here's the command here. So I'm going to type describe, and then in parentheses, I want to describe this entire data set, LQ 2002. And then I put an option here that is fast equals true. So fast equals true. And I can run this either by pushing play or control enter, and we get a nice summary. Now you might notice something's a little different here. Notice that I put psych and then in 2 colons in front of describe. This is a trick that's called lazy loading. Lazy loading. Now, the reason you do this is because there actually are several different packages that use the psych the function called describe. So there's a describe in psych, but there are other packages like the HMISC package that we learned about last week. HMISC also has a version of describe as well. And so sometimes when you have, and this is also when you start up, you sometimes get these messages about how one function sort of replaces another. And what that means is they're sort of fighting for which function is going to get the first pick. So when if I don't know better and I just type describe and I have 2 packages that both have a describe function, which one is going to supersede the other? And in this case, let's see if there's anything in here. No, in this case, we're good. So notice when I start typing describe, the first thing that comes up is describe. And in the brackets here, that's actually the name of the package. So psych actually pops up here. But as an example, let me show you. So let me turn on the HMISC package and show you what happens, because I know HMISC also has a describe function that does something different. So, okay, so there's HMISC, and I can load it in this way. You don't actually have to type library if you don't want. You can just click the button. So, okay, HMISC is in here. And notice you get this warning on the lower right-hand corner. It says, the following object is masked from package psych, describe. The following objects are masked from dplyr, src, and summarize. There it's telling you, okay, this package is going to supersede all those others. And so notice what happens when I start typing describe. Haha. The first choice that pops up is no longer psych, it's HMISC, because the HMISC package was the last one that was loaded. And so it thinks that that's the one you want to use. So anyway, long story short, the way to get around this is to say, no, I want to use the psych version of describe. And you do that by typing the name of the package and then 2 colons. So that'll make absolutely sure, even if you have a package loaded that is competing with that with the function that you want, you always get the one that you want. Okay? All right. So here we have the statistical summary of this data set. So we have, again, our ID variables, which are here. We have lead 01 to lead 07. And notice these all have a min and a max of 1 and 5, respectively. And that's typically the scale is from 1 to 5. The mean of these items is somewhere between 2 and 3, sometimes as high as 4. Here are the T-sig items. Again, these run from 1 to 5. The mean is somewhere between 3 and 3.5. And then our hostility score runs from, interestingly, 0 to 4. So for whatever reason, that one's scored on a slightly different scale. And the mean here is 1.5, a little below 1, and 1. So you can already sort of think in your head the mean of, even though hostility is measured on a slightly different scale, it looks like most of the responses are to the left side of the distribution. So we've got maybe a right skew in that variable, but we can check that with a histogram as well. Okay, so now we're going to talk briefly about scale scores and reliability. So I'm hoping that this is not the first time you've heard the term reliability, and this is a really important concept in measurement. So if we have a construct that we're interested in, and we've measured it quantitatively, say on a survey scale, we need to provide some evidence that what we've measured is reliable. And one way of doing that is to say, okay, I asked 5 questions, for example, all about the same concept. And now I want to know, how similar are these 5 questions? Could these 5 questions hang together as one sort of latent construct? And that, of course, gets us into latent variable modeling and factor analysis, which we're not going to get into. I teach a multivariate course in the spring where we spend much more time talking about factor analysis and EFA versus CFA and some of those other options. But for now, I just want to sort of show you a quick and dirty way that if you have a scale in a data set that has been well validated and used before, you can use these tools to calculate a scale score and then test its reliability, which is really what you want to be able to do. So the first thing I want to show you how to do is to calculate what's called Cronbach's alpha, which is perhaps the most basic, simple, straightforward measure of reliability. This is a scaled inter-item coefficient, correlation coefficient for a set of items. Is alpha the greatest thing since sliced bread? No. In fact, there are numerous problems with it, but the advantages to alpha is everybody kind of knows what it is. And the standard generally is you're looking for a scale with an alpha of about 0.7 or above to be considered to have reasonable reliability. There are a lot of issues with that. There's a statistic called omega, which is in many ways more realistic. And the psych package will also calculate omega for you, which is great. So you don't have to stick with alpha. But I want to show you how to do alpha because it's just one of those things that we tend to have to be able to do. So the way psych works, you need to calculate an alpha, you need to only provide psych with a small little data set that is only composed of the items that make up the scale. So in this case, we have a big data set, LQ 2002, that has all the items, including a bunch of items that aren't from the same scale. So what I'm going to do here is I'm going to create another little mini data set here called hostile items, because I'm going to check the alpha, the reliability score for this measure of hostility, because this is going to be my outcome in my models. So I'm just going to give this a name here, and here I call it hostile.items or underscore items. And again, the assignment operator. So it is defined as, first, start with my big data set, LQ 2002. And then, oh, there's that pipe operator again, always being difficult. And then I'm going to select from that data set just these items right here. And I'll show you again, this is a case where we have to use this lazy loading trick because select is actually not, oh, it actually does pop up. Cool. Sometimes, oh, I guess that utilities is the other function, but select popped up right away. Okay, so we're going to select, and then the items are going to be hostile 01, and then hostile 02, hostile 03, hostile 04, comma, new line, hostile 05. So those are my 5 hostile items. I should have mentioned earlier too, there's a more detailed code book for this data set, both in the paper, the Gavin and Hoffman paper, and also in the appendix of our class textbook. Garson provides a lot more detail on what exactly all this stuff means. Okay, so I'm gonna run just this little chunk, and notice I have a new data set up here, a new data frame, which is 2,000 observations and only 5 variables. So if I click on that, sure enough, this is what I want. This is a small little data set that is just those hostile items. Thank you, dplyr. And so now I can just run the alpha command from psych, and it will calculate a Chromebox alpha just on those items. And I'm going to go to, it's going to give you a lot of output. It's actually going to give you 4 different sets of output, lots of different information. The most straightforward is all the way to the left, and that is your alpha. So here it is. You get a 95% confidence interval. Alpha is 0.87, and the 95% confidence interval goes from 0.86 to 0.88. So that's pretty good. Again, we want alpha to be above 0.7. And we, in theory, would really like the 95% confidence interval to not, the lower end to not contain 0.7 either. We want it to be above that. But this is well above that threshold, which is really nice. You also get 3 other sets of output with a lot of other information. So here's what's a raw alpha, here's a standardized alpha, average correlation, different measures of error and variance. I'm not going to go into those too much. I will go to the furthest data frame on the right here. So this is this can be useful when you're trying to diagnose problems with your scale. So here we have R drop and R core. So these 2 columns are really helpful for identifying items which are not playing well with the rest of your scale. Because sometimes you have 1 or 2 items that just don't work. And so what R drop tells you is, what would be the alpha of the scale if that 1 item were dropped? And ideally, you want all of these to be below what the alpha of the scale is with all items included. And that's the case here. So alpha with all items is 0.87. And if we drop any of these, alpha is actually going to go down. So that's a good sign. It means the items we have sort of hang together pretty well. The other useful tool here is R core. And that is, what is the correlation between a single item and the rest of the scale? And so we want all these to be pretty high too. And they all seem to be pretty high. So if you do have problems, R drop and R core can be nice places to look for outlying items that might not play very well. Okay, so there is a crash course in alpha. Woohoo! Again, lots more to it, but if all you're doing is calculating scale scores based on an existing survey, then you're good to go. So that brings me to my next task, which is actually calculating scale scores. So again, we're going to use the psych package to do this. It's not quite as efficient as in a commercial software like Stata, which is kind of a bummer, but it's not too hard to do. So let's say we want to now create, we got an alpha for these 5 hostile items. And what we found out was that those 5 items actually do a pretty good job of holding together into one latent construct. And so let's calculate, now we want to calculate a scale score that represents that construct. So to do this, the first thing you do is you define a key, and then you score your items according to that key. And then you have to do a little bit of wiggling to get those items back into your original data set. And I'll show you how to do that. But the first thing you do is you define a list, which is all of your scales that you want to estimate and the items that they're comprised, okay? So here I'm calling my list my keys list. You can call it whatever you want. And then my assignment operator. So this is a list. And here I'm saying I want a new variable called hostile. And it is going to be made up of these 5 items. And notice here, this is a character vector. That's what the C is. So it's a vector of names. So I have hostile 01 in quotes and then a comma, not in quotes, hostile 02, hostile 03, hostile 04, and hostile 05. If I had a hostile 06, I could put a comma on there and then type it right there. If I had another scale, I could put a comma after this and add another scale. So let's say I wanted to calculate tsig. I could type tsig is equal to a character vector, and I could start typing here tsig 01, tsig 02. Oop, that needs to be in quotes. And so on and so forth, and outside the quotation marks, and tsig 03. So that would add another scale score that will be calculated. So what's nice is you can actually list all these things. You know, if you're calculating a bunch of scale scores, you can actually list them all here, and they all sit in this one list. But for now, I'm just going to show you how to do the one for hostile. So I'm going to get rid of this, like so. Okay, so I'm going to run that line. And notice I now have a new list, a list of 1. And if I click on this, here's my list. These are my 5 items. And Psych is going to use those. And now I'm going to define my dot scales. So now I'm actually going to score my scales using the items that I've specified up here. So the command here from Psych is score items. And then the first option in there is what are your keys? And my keys are hidden right here. The second option is where's the data? The data are in LQ 2002. Notice I can do the larger data set. I don't have to just shrink it down into the smaller one now because it knows which items to look for. And then the third required command is do you want to impute data or not? Now this is kind of cool. It will it'll actually impute a median value, or it'll do some multiple imputation for you to replace missing values. In this case, we don't have any missing values, and so we can just put impute equals none. But there are a lot of cool options for what you want to do to handle missing data at this step. So that's the command, and that's going to give me a new object called my.scales. So I'm going to run that. And my.scales is a big object. It's got a lot of stuff in it. It's got scale scores and other stuff. So again, if I hadn't run my alpha command above, if you just do print my scales, it will, and then short equals false, meaning you want all the output, it will give you a lengthy psychometric report on all of your scales. So here is hostile. It has an alpha of 0.87, a standard error of 0.01. Here's the correlation. You get some other stuff like Gutman's 6 reliability, some other median item correlations. You get a summary of missing data, which is pretty cool. So there's a lot of cool stuff that you get here. So you really don't need to do both. You don't need to calculate alpha and then this. So if you're going to score your items anyway, you can just do this to get your alpha. Okay, so now what I need to do is I need to grab those scores that have been calculated, And I need to turn them into data that I can actually do math with, because right now they're just sitting in this list of 19 things. And so if I clicked on my scales, it shows you all the different things that are in this list. So sometimes, so these are all little individual mini data sets and measurements. The thing I need is this one right here. I need the scores, because that is a 2,000 row by 1 column data frame with a new score for every person for hostile. So that's the thing I need to grab. So I'm going to do that by saying, I'm going to create a new data frame, new data set. I'm going to call it my.scores. And that is going to be basically created by grabbing just the score component of that list. So my scales, $, and when you type this, when you're typing my.scales and you do $, it'll show you all the things that are in that object. And I just want the scores. And then this command as Tibble. Now, I don't want to go too far into this because some of this may not be stuff that you need to know right now, but Tibble is basically a form of a data frame in R that's really easy to work with. So basically, we're going to take those scores and we're going to turn them into a data frame that we can work with. So I'm going to run that, and I get a new data set up here, which is just, notice, hostile. It's a hostile score for all 2,000 people in my data set. Okay. All right. So now I'm going to, the last thing I need to do, I need to take my new variable that I've calculated and I need to attach it to my old data set. So the command to do that is bind calls for columns, bind columns, okay? So I'm gonna create a new data set that I'm gonna work with. I'm gonna call it LQ 2002.1, just to make it different from LQ 2002. And it is going to be created by binding the columns of LQ 2002, which is my original data set, and my.scores. So what it's going to do is it's going to take all the data that's in LQ 2002, and then it's going to take that one extra column and it's going to stick them together. That's what bind columns does. And bind calls will only work if the two data sets are the same length. So in this case, how many rows? So my.scores has 2,042 observations. LQ 2002 has 2,042 observations. That's good. It's going to stick them together, which is exactly what I wanted to do. So I'm going to run that. I'm going to get a new data set. And here is LQ 2002.1. And notice it has 29 variables instead of 28 variables because I now have my hostile score in there too. And then I'm going to glimpse, and sure enough, down here at the bottom is my new variable hostile. So I've taken my calculated scale scores and I've attached them to the new stuff. So I showed you how to do this for one. You can do this for as many scale scores as you want at once. All you have to do is fill out that key list part, mykeys.list. You just need to add more scales there. And what it's going to do is it's going to calculate them. Then you're going to grab them and you're going to move them over to the data set you're working with. And in this case, you know, Garson did this for us. So I know you're probably saying, what? Why did we spend all this time? I just wanted to show you how to do it. And we can even double check. So here is Garson's scale score and here's our scale score. And we can compare observations. So 0. So person 1 was 0 here, 0 there, 1.2, 1.2, 0.4, 0.4, 1.8, 1.8. So that's good. That's just a spot check that what we actually did actually worked, which is really what we want to do. All right. A couple other quick things we can now do. We're going to visualize 3 key variables. Now, the commands here I've showed you before, so I'm going to go a little bit faster through these. So the first variable we're going to look at is hostility or hostility score, so how hostile someone is to the mission. And again, we're going to use histogram as our command. And then, of course, you can change all this. This is the title, this is the subtitle, and this is the x-axis. So when we run that, we get a nice little histogram here. So this is pretty heavily right skewed. A lot of the observations are, most people do not have too much hostility towards the mission, but there are some folks that do have, or there are some that have some hostility out here, but most people are kind of between 0 and 1. And then this is task significance. So a little bit more of a spread here in terms of how important people feel their work is. And here is the distribution for leadership climate. So how effective do you think your leader is? And again, it's pretty well normally distributed. Most people sort of in the middle when they reported their answers. And those are, of course, the scale scores that are calculated from the individual items in the data set. Okay, so let's recap. We started with the data set LQ2002.CSV up here above. We inputted it and we glimpsed it to get a sense of how it worked. We used the psych package really extensively here. So we used psych to create a summary of all of our variables. We also learned about lazy loading, which is something sometimes you need to do when you have competing packages that have the same function name. Then we covered reliability in about 10 minutes. That was pretty fast. So we talked about how to calculate Chromebox alpha, very briefly, what it represents, what we're doing. We made a little small data set of items to calculate alpha from for our hostile measure. And then I walked you through the process of creating a key, scoring your items, getting some more reliability information, and then attaching those scores back to our original data set. So all of that, hopefully very useful techniques that you can take into your own work. And next up in part 2 of the video, we actually run the multi-level models and talk about what it means to add predictors. So hope that helps, and I will see you soon.